This is the second video for section 9.1, transformations. And we're going to try to see what happens, how we would translate something up and down. And so I've got this function y equals absolute value of x plus 2, where the plus 2 is outside of the absolute values. Right. So this is translation or shift. The graph of the basic function y equals absolute value of x, it shifts that graph up by 2. Okay? So this is the basic y equals absolute value of x. Again, like I had on the previous page, its vertex is at 0, 0. And then we want to graph y equals absolute value of x plus 2. Now, if you're ever confused, just start plugging in numbers. If I plug in 0 there, I get 2, right? Now, how do I know that's the vertex? Well, I could plug in 1 and I get 3. Plug in 1 for x and you get 3. Plug in -1 for x and you get 3. You can see it's symmetric about that point where x is 0. So it always works that way. The argument of the absolute value, the graph is going to be symmetric about where that is 0, which is why setting the argument equal to 0 tells you left and right which way to go. Here, it's like x minus 0 inside the argument, right? There's not a left or right shift at all. It's an up and down shift. And what's happening is, if you look at the left, you have y equals absolute value of x. So y is absolute value of x. So think of absolute value of x is our first y. Now in the second graph, we're changing y. What did we do to y, which is the absolute value of x? What did we do to it? We added 2 to it. So for every point on the graph, we've added 2 to the y coordinate. Okay, so hopefully that makes some sense for you.